Okay, this is 1.3, and we're going to be talking about a term that we call compound interest, okay? As opposed to earning simple interest, we're going to be talking about compound interest, and it's very important to know the difference between the two. Now, what compound interest is the interest calculated on the principal and the interest earned. It's usually done if your time is more than 1 year. Okay, so it's calculating interest on top of the interest that's earned, but we have to see what that looks like. And there's a formula that we're going to be using, but it's important to understand where the formula comes from and why we use it. And in that formula we have exponents. So we're going to have to know how to use exponents on our calculator, and we're going to have to still know how to use order of operations. Okay, so when you have your calculator handy, we want to make sure that we understand how to use exponents. So I've got the first one, 3 cubed. Well, on this one here, if you have a calculator like this, a TI-83 or TI-84, you've got an exponent button. You can use your squared, or you can use your e to the x, okay? But what I like to use is I like to use the up arrow here. Okay, every calculator is different, but with my calculator here, the up arrow is a great way to use my exponents. So 3 to the power of 3 means 3 cubed, so I can just take 3. Well, let's clear that. Let's take 3, and I'll go up arrow, and that means it's going to put it to the exponent of 3, so that's 3 cubed, and I get an answer of 27. So that's just 3 times 3 times 3, which is 27. Okay. Next one here, I've got 2.5 squared. Well, I can just put in 2.5, and I actually have a squared button, so I can just hit that. And you can see the little number goes right there, the exponent, and I hit enter, and I get 6.25. 6.25. Over here, I've got 2 plus 3 to the exponent of 4. Well, I have to follow BEDMAS. BEDMAS is order of operations, brackets, exponents, division, multiplication, adding, subtracting, or addition and subtraction. So I have to do what's in brackets first. So this is bracket 2 plus 3 bracket to the power of 4. I have to do what's inside the brackets first. So I have to take the 2 plus 3, which is 5. And this is the same as 5 to the power of 4. So that's 5 times 5 times 5 times 5. Okay, so I'll clear this. I'll take my calculator. I'll do 5, and I'll do to the exponent of, or up arrow, 4. And I get an answer of 625. Okay. 1 plus 2.1 to the exponent of 3. I have a bracket around here, so I have to do that first. So this will be 1 plus 2.1, which is 3.1 to the exponent of 3. So I'll take 3.1, and I'll put it to the exponent, or up arrow, of 3. And I get an answer of 29.791. 29.791. Okay, so you can see placement of brackets is very important, because we're going to need to know that for the compound interest formula. Okay, so let's go to a problem. Madeline invested $10,000 4 years ago. The investment earned compound interest at 2.1% per year, compounded annually. Compounded annually means it's compounded once a year, at the end of the year. She will use the interest to buy equipment for her cupcake business. How much interest does Madeline have for the equipment? Okay, well, it's very important to understand how the compound interest formula works, and we're going to try to explain that to you here by just starting out with simple interest and how we get the compound interest calculated. Okay, so we know that she's investing it for 4 years. So here's year 1, 2, 3, 4. We know that interest is calculated at the end of the year, which is over here. So in year number 1, we're going to use the simple interest formula, I is equal to PRT. She started out with $10,000. So we'll plug the numbers in. 10,000 times 2.1%, which is 0.021, times the number of years, 1, and it means that she earned $210. So the amount that she's going to have at the end of year 1 is going to be her original principal, okay, $10,000, plus the interest she earned is $210, which means at the end of year 1 she's going to have that much money, $10,210. So at the beginning of year 2 and all of year 2, she starts out with $10,210. That's what she has now in her bank, because the interest was calculated at the end of the first year. And now at the end of the second year, she's going to have this much money, 10,210. The interest rate is still going to be 0.021. It's still going to be for 1 year. But we now, instead of putting in $10,000, she doesn't have $10,000 in year 2, after year 2. She's got 10,210. That's what she's investing. So now this answer comes out to she's earned $214.41. So now, at the end of year 2, she's got what she started with at the beginning of year 2, which is $10,210. Plus the interest that she earned on that 10,210, which is $214.41, which means at the end of year 2, she has $10,424.41. Okay? You just don't calculate simple interest again on the $10,000 and then just keep doing it that way. You earn interest on the interest. That's what the word compound interest means. It means earning interest on top of the interest. So now at the beginning of year 3, she starts out with $10,424.41. She's going to invest that, so let's put that in there, $10,424.41. The interest rate is still the same, 0.021 or 2.1%, still for 1 year, and that means that the interest she's going to earn on that is going to be, just do the math on your calculator, $218.91. So the amount of money that she's going to have at the end of the 3rd year is going to be what she started with in the 3rd year, $10,424.41, and we're going to add to that the interest she earned on that, which is $218.91, which means she's going to end up with $10,643 and looks like 32 cents. Okay, at the end of the 3rd year. So she takes that, she reinvests it again for the 4th and final year. So we have $10,643.32 here. So the interest she's going to earn on that is going to be that principal she's starting with in the 4th year, $10,643.32 times the interest rate, 0.021, times 1 year. And that means in that 4th year, she's going to earn $223.51. So the amount of money she's going to have after 4 years is going to be the $10,643.32 plus the interest, which is $223.51, which means after 4 years, she's going to have $10,866.83. Okay? Now look how many calculations we had to do here. We had to do for year 1, year 2, year 3, year 4 using the simple interest formula. And that is long and that is tedious, and who wants to do that? Supposing I asked you the same question, but I said she invested it for 15 years. You'd have to do this 15 times using the simple interest formula. Now there's got to be an easier way, and it just so happens that there is. Mathematicians came up with a formula called the compound interest formula, okay? And basically what that is, it's a shortcut, okay? So we're using the simple interest calculations in the chart to determine how much compound interest Madeline earned. So after 4 years, Madeline's investment was worth $10,866.83. Okay, you can see right here. We're going to subtract the original $10,000 investment, which means that she earned after 4 years $886.83. Okay, $866.83 was the interest. Okay, so at the end of each year, the interest earned is added, right here, very important, is added to the principal. The sum is the principal for the next year, and you can see that we transferred or carried this number over to here. Okay, this number here over to here. That's using simple interest. Like I said, there's got to be an easier way. Well, it just so happens that there is, and there's a formula that you're going to use, and it's called the compound interest formula right here, where we find the total amount that's earned with the principal, and then using this part right here, which is the interest per compounding period. Okay, so let's take that same example and let's plug the numbers in and see if we can find a faster way of doing that same calculation. Okay, so let's use the compound interest formula to calculate how much interest Madeline earned. What information do we know? We don't know the amount. Okay, that's the question mark. We do know the principal. What did she start out with in the question? Well, she started out with $10,000. The interest rate per compounding period is 2.1% per year, or 0.021. And the number of compounding periods, N, how many years? N is time in years. There was 4 years. So all we do is take this information and we're going to just plug it into this formula up here and see if we can come up with a faster way or shortcut way of doing this. So the amount is equal to the principal, 10,000, times 1 plus the interest rate. What is the interest rate? 0.021. We have to put it as the rate here, not as a percent. If you put it in as a percent, you'll get a wrong answer. So now we just do the math. Okay? So we take our calculator. Let's turn it on. Let's clear this out here. And I'll move it over to here. And we have to follow order of operations. We have to do brackets first. Okay, so we have 10,000 times bracket 1 plus 0.021 bracket all to the exponent of 4. We have to do order of operations. We're going to do what's in the brackets first. This is absolutely important. If you forget this step, you'll get a wrong answer. So 1 plus 0.021 is equal to 1.021. Okay, then we have to do exponents because we follow BEDMAS. B is brackets. E is exponents. We do exponents. So now I'm going to put it to the exponent of 4, and I'm going to get an answer. I'm going to hit enter. And I get this decimal right here, 1.086683, etc. Then I multiply it by my principal, times 10,000. And I get an answer of 10,866.83. 10,866.83. Do you recognize that number? That's the exact number that we got when we did it with the simple interest and carrying it over for 4 years. But here I got that exact same number just by plugging it into one simple formula. So how much interest did she earn? $10,866.83. Subtract the original investment of her principal of $10,000, and she ends up with $866.83. So you can see calculating simple interest isn't that hard if we use the formula. Okay? Example 2. Owen sold his auto body shop in Regina. He invested $80,000 in his savings account that earned 2.75% per year, compounded annually. That means every year. How much will Owen's savings be worth after 3 years? Now we could use the simple interest formula and we could do it like we did on that chart before and just do it for 1 year, carry it over, do it for another year, carry it over again, do it for another year. But there's a faster way, and let's use the simple interest formula. The amount is equal to the principal times 1 plus the interest rate to the exponent of n. Okay, so let's plug in the numbers. His original investment was $80,000. The interest rate is 2.75%, which is 0.0275. N is 3 for 3 years. Okay, so let's take our calculator. We'll clear it. We have to do what's in brackets first, so 1 plus 0.0275 equals 1.0275. We have to put it to the exponent next, which is the exponent of 3, get an answer, and then we're going to multiply that by $80,000, and we get an answer of $86,783. $783.16. So Owen's savings after 3 years will be worth $86,783.16. Okay, so you can see using the compound interest formula is a lot easier, a lot faster than using the simple interest formula and carrying everything over and making a big long chart for the number of years you have. Okay, this is much quicker, much faster. Okay, all right, try some of the practice.